All right. Hi. So this is the first video kind of trying to explain the review to you. I'm going to be referring to this is like a filled out version of the review and also the formula chart because everything involves the formula chart. All right. So the first questions are about quadrants, asking what quadrant could this be? So quadrant meaning quadrant 1 is 0 to 90, quadrant 2 is 90 to 180, quadrant 3 is 180 to 270, and quadrant 4 is 270 to 360. Okay. Um, so 1 through 4 wants to know what quadrant this is in. Well, 30 that's obvious. That's quadrant 1 because it's between 0 and 90. Now, the rest of them aren't so obvious because they're numbers that are either in radians or they're numbers that are like bigger than 360. So if they're bigger than 360, first thing you do is subtract 360 or even 720, maybe. Could be a bigger multiple of 360 so that you find a number between 0 and 360. Like number 2, it says 490. So you subtract 360, you get 130. Like 130 degrees on a on like a polar coordinate is the same thing as 490, and 130 degrees is in quadrant 2 because that's between 90 and 180. Okay. All right. So 3 and 4 are radians. I recommend changing the radians to degrees. It's easier for me to identify what quadrant we're in if it's in degrees personally. So if you multiply the radian times 180 over pi, that changes it in 2 degrees. So like number 3 becomes 690, and 690 is more than 360. So I subtract 360, and then I get 330, and 330 is in quadrant 4. Here, you multiply that times 180 over pi, you get negative 120. All right, so when it comes to negative degrees, I wouldn't be subtracting 360. I'd be adding 360. That makes it be a positive number between 0 and 360, and you get 240, and that's quadrant 3. All right, so 5 through 8 want reference angles. Reference angles are what that means is I want what is the quadrant 1 equivalent of it. So like if it's a quadrant 1 angle, that's the answer. If it's a quadrant 2 angle, you do 180 minus whatever they give you. That'll make it a quadrant 1 angle. If it's a quadrant 3 angle you're given, you do the angle minus 180, and that gives you the quadrant 1 angle. If it's a quadrant 4 angle, you do 360 minus the angle, and that gives you the quadrant 1 angle. So for number 5, we're given 700. Well, 700 is more than 360, so we need to make it some number between 0 and 360. Well, I subtract 360, I get 340. All right, 340 is a quadrant 4 number, okay? So then I do the quadrant 4 thing here. I do 360 minus the angle, and 360 minus 340 is 20, and 20 is an angle between 0 and 90, so that's the answer. Number 6 is a negative 390, so I add 720 because adding 360 is not enough. Adding 360 would just keep me at negative 30. I want a positive number. So I add 720 because that's a multiple of 360. I get 330, and 330 is quadrant 4 again, so I do 360 minus 330. The quadrant 1 equivalent is 30 degrees. All right, 7 and 8 are in radians. So um, I didn't change them to degrees. I did the radian way of doing everything. So 2 pi is 360. All right. So like that's just another if you look at the formula chart, you really ought to remember things like 0 is 0, 90 is pi over 2, 180 is pi. So that happens quite often. We're going to be subtracting pi. 3 pi over 2 is 270, and then 360 would be 2 pi. All right, that's just something I hope you remember. So 20 pi over 9 is just by the picture, you notice it is something greater than 360. So I would subtract 2 pi. And because if you change 20 pi over 9 into degrees, that's 400 degrees. And so if you subtract 2 pi, that means that we're subtracting 18 pi over 9, because when you subtract or add things with unlike Denominators, you have to make it have the same denominator. 9 times 2 is 18. So now you have 20 pi minus 18 pi over 9. That creates 2 pi over 9. 2 pi over 9 is in quadrant 1. It is. It's the same thing as 40 degrees. That's 40 degrees. Okay, so that's actually the answer is 2 pi over 9. All right, so for number 8, they give us a negative radian. So instead of subtracting 2 pi, I would add 2 pi because that would give us a positive number. And if you do that correctly, you end up with the same answer. Like, actually, if you notice, like the picture for 7, 8, they're both the same picture. It's just the spirally thing is different, really. That's all that is. All right. Okay. Number 9, 10, 11, 12. They want you to identify the trigonomic ratio based on the information you're given in the picture, and you're given a coordinate of -4 and 3 for the first two, for 9 and 10. And basically what that means is you have a right triangle with an adjacent side of -4, with the angle being here, and an opposite side of 3. And for both of them, you end up with a hypotenuse or a radius of 5, because Pythagorean theorem, when you do 3 and -4, you get 5. That works for both of these. It actually works for all 4 questions. And so now you have 3, -4, and 5. And it wants cosecant. So cosecant is hypotenuse over opposite, which becomes 5 over 3. 10 wants the reciprocal of that. That's sine, which is opposite of hypotenuse, and that becomes 3 over 5. All right, so for number 11 and 12, it's in quadrant 3, and when it's in quadrant 3, that means both the x and y are negative. So like 9 and 10 was quadrant 2, and that's when the x value is negative. That's why the -4 is negative. But for 11 and 12, it's the x and y are both negative. And but the hypotenuse or radius is not. It's positive 5. So 11 wants cosine. So cosine would be the -4 over the 5. Again, you're going to get the same answer with Pythagorean theorem. If it's negative or positive 3 and 4, you get 5. And then cotangent is adjacent over opposite. So that's just asking for what is -4 over -3, which simplifies down into positive 4 and 3. Okay, number 13 is a angle of elevation question. This picture is my picture of what this is saying. So Brian's kite is flying above a field. Here's the kite at the end of a 65-meter string. So that is a diagonal string. Okay, you know, when you fly a kite, it's not perfectly vertical or perfectly horizontal. It's diagonal. So this is like the hypotenuse, essentially. If the angle of elevation to the kite measures 70 degrees, like you're here, here's 70 degrees, how high is the kite above Brian's head? So that means you're solving for the vertical height. And so you're given the opposite, you're solving for opposite. Sorry, you're given the hypotenuse, you're solving for the opposite. That means you're doing sine. So sine 70 is x over 65, and then you work this out. The answer ends up being about 61.1. Okay. All right. 14, 15, 16, 17. Okay. So these are asking for a lot of stuff, and it's mostly about your understanding of the first chart you see. It's really this stuff, okay? The A being amplitude, the B being period, C is phase shift, D is vertical shift, but D is also the midline, okay? That's whatever the vertical shift is also the midline. It's the same thing. Okay, so we have this equation here, y equals 3 cosine theta minus 135 plus 1. Okay, so the amplitude's 3 because it says a 3 in front of the cosine. Now, why is the period 2 pi? Well, if you don't see anything next to theta, that means it's not 1, it's 2 pi. And the reason why it's 2 pi is because, look at the formula, is 2 pi over b. So if you don't see anything here, that means it's 2 pi. So these questions, I recommend graphing them in Desmos so you can kind of see what it is. Like here's what that question says, right? Here's what 14 says. And so it has an amplitude of 2. The reason why this amplitude 2 is because this has a midline at 1. In the middle of it's 1. The highest point of it's 3. 3 minus 1 is 2. Yes, so this is the midline. Whatever that is the midline. If you notice, that is the middle of this graph. This does have a period of 2 pi. And the reason why it's 2 pi, well, so 2 pi over 2 pi is 1. That's why you don't see anything here. If you don't see anything, that means the period is 2 pi. And just so you show, the period is the distance from one maximum point to another. If you were to do this 3.05 minus 2.23, you would get essentially what is 2 pi, which is like 6.3. And it has a phase shift of going to the right of 135 degrees. Okay. Yeah, so for these questions, I recommend graphing them just so you can visually see it. But you don't need to graph them to get the maximum and minimum. If you know the midline and you know the amplitude, you can figure out maximum and min. It's like, all right, so the maximum is if you do the midline plus the amplitude. 1 plus 3 is 4. Also, the minimum would be the midline minus the amplitude. 1 minus 3 is -2. It is. Or also, you can just look at the graph. Here's a maximum of 3. Here's a minimum of -1. -1. Yeah. Oh yeah. Sorry. This should say 3. There we go. 4. Now it makes more sense. 4 and -2. There we go. Yeah. So now it has that. Okay. And that's how you do those. That's how you do really all these. It doesn't really matter if they're in radians or not. Make sure you are in radians when you graph these. All right, like it doesn't really matter if this is degrees or radians. Like it only graphs correctly with the radians. So if you make it degrees, it looks like a straight line. Radians is not. So that's how it is. Okay, so that's how you do 14 through 17. That's not that big of a deal. 18 is the other way around, like you're given a graph, you got to figure out the equation. Well, it is, in my interpretation, y equals 6 sine x minus 2. All right, the reason it is because if you type in just like regular y equals sine x, like, so it says it wants a sinusoidal one. So here's regular sine x, right? Regular sine x goes to the middle at 0, 0. It has a maximum at 1, a minimum at -1. It has a period that is 2 pi. Okay. Now, what is this? Well, this has a middle at -2, so that's why it's -2. It has an amplitude of 6 because the maximum is 4, but the middle of it's -2, so that's why it's 6. It does start at the y-axis, so it didn't phase shift left or right at all. And it does have a period of 2 pi because this spot to this spot is 360 degrees. So see 0 all the way to 360, and that's what 2 pi is. So that's why it's just x. And that's why, for me, the answer would be is y equals 6 sine x minus 2. And 19 is a little bit tougher because it shows it actually phase shift. It phase shift about pi 3 to the right. And so the midline was -2. It has an amplitude of 3 because -2 plus 3 is 1. It has a max of 1. It also has a minimum of -5. So like -2 minus 3 is -5. And it has a period of 3 because the space between these two maximum points is 2 pi over 3. So 2 pi over 2 pi creates 1, but well, we have 2 pi over 3 differences, so that means it would be multiplying times 3. Okay, that's what that is. And okay, and then 20 is, you just plug in that equation, you plug in f of 30. So you just really write this equation in Desmos, and then you plug in f of 30, it gives you about 1. And then if you graph this, you'll notice that there's a point where it touches 0.5 is about 0.5.